Hello everyone, this is Imran. In this video, I'm part of IBM Workshop Group 1, and in this video I'm trying to explain what I have done using the complaints data of United States, and try to build models and see what are the characteristics which make a complaint in the winter season of the United States. For this we have two data sets. One is 311 dataset where we have all the complaint information, and how it contains complaints like heat complaint, or what sort of complaints we have received for each borrow, and all the zip codes. And in the other Pluto dataset we have the data regarding the building characteristics, its area, its when it has been built. And using these two datasets, and we are trying to see which characteristic is most important for anything to get a complaint. And these one our data sets are stored in HDFS in the IBM Bluemix. And we have this is we have written two programs. First is Scala language program, which is running on version Spark 2. And for this we have created this object storage, and we have created the Spark service. And uh, we have used these credentials in our Scala language and try to connect to this service in Bluemix. And it will connect to this service using REST API. And for executing this SQL statements on Scala, we have imported this library org.apache.spark.sql.spark session. And here we have given our credentials, uh, and then for the Spark service. And we have first read this SI. We have so many borrows, and specifically we have 6 borrows. So we have one dataset which is only specific to one borrow SI. So we have just uploaded so as to test whether it's working or not. And then we have imported our first dataset, which is 311 dataset, which has got all the complaints for each borrow. And as we can see here, there are 1.6 million complaints received. And we have seen what are the borrows we have in these complaints. We have 6. And we have seen we want to see how many complaints are received for all the borrows for different types of complaints, and how many what are the count for those complaints for each borrow. And then we have used this Brunel library in our Python notebook. And we have using this jar library. And we have seen this here, that the street condition is the most common complaint for all the borrows in the United States, followed by illegal parking or street light condition, and then water system, and then heat water. Here is we want to do some analysis on this small circle heat and or hot water. And here we have seen in for each zip code how many heat water complaints only specific to heat water has been received here. And then we have seen here what are the maximum, minimum, and average complaints received for heat water. And then we have seen here for each incident zip specific to each zip code how many heating complaints has received and what are the dates. And then we have stored this where in our data frame called address NYC aggregation data frame. And we have seen here now we want to see the density for each zip code. It is equal to complaints received for each zip code by number of buildings. So here we have seen before that we have seen here how many complaints for how many count of zip codes received which has received one complaint, and how many count of zip codes which has received 2 complaints. And also those kind of count we have done. And we have given this distribution here, how many incidents, and how address here. And now we have seen only one data set which is only related to complaint. And now we want to see the data on building characteristics, which has got building area and when it is constructed and everything. And it is also stored in HDFS. We have connected this here. And can see the schema using this statement. And going down, we can see here we are storing this into this data frame, a Pluto data frame, where we have zip code and number of buildings and building area and its axis, and we are trying to merge the first dataset with this dataset using this statement here, and we can see this only 12 zip codes has been matched for both these datasets, and we can see here the rows of related to those zip codes. And later on we would like to see the density as it spoke before. Density is number of buildings by number of complaints by number of buildings in the zip code, and we have for each zip code here we have seen the density and everything, and we have given a pie chart distribution of if the density is less than 0.1, it is low complaint zip code dense area, and if it is high greater than 1, it is considered as a high density complaint. And we have saved this data in our object storage, and instead of saying into HDFS, so as to again reuse this data for building our models. And as we can see here, we have saved this data in SI output 1.csv. As we can see here, I have stored in IBM big data project. As first data is SI output.csv, and the second data, this 12 rows has been saved into this, and the second Pluto data has been stored in this data frame, and saved into this data set name called it's specific to SI, so I've given the wrong name here, SIAGR data.csv. And in the next program, which is R program, we would like to use these data sets for building our models.